Hello everyone and welcome to Equations of Linear Relations lesson number 3. So in the last couple of lessons we've looked at the form of the linear equation y is equal to mx plus b, where m is the slope and b is our y-intercept. But there are other ways to write the equation of a line using different information. So today we're going to look at point slope form, it's called. And where it's y minus y1 is equal to m multiplied by x minus x1. So let's go through a couple of investigations here, and then we will get to it. So here we go. Here's a line. The graph of y plus 3 equals 2x minus 1 is shown on the grid. Determine the slope of the graph. So we have to find, it looks like we can use a and that point right there. So the slope is going to be rise over run. So I'm 1, 2, 3, 4. I'm plus 4 on my rise and plus 2 on my run. So the slope is 4 over 2, which reduces to 2. List the coordinates of point A on the line. So point A is at x is 1, y is negative 3. So 1, negative 3. And then it says compare your answers in A and B with the numbers in the equation. So you can see here we have our equation is y plus 3 is equal to 2, x minus 1. Minus 1. And you can see that the slope was 2, and it looks like that value is 2. And then the x value of that point A was 1, and we have a 1 here. And the y value was negative 3, and we have a positive 3 here. So just I'll show you what's kind of happening here, and we'll talk more about it. So the general form of the point slope form is y minus y1 equal to m x minus x1. So this y here and this x, those are just general variables. We just leave those as y and x. We don't put a value in. But the other ones are going to get a value. So we know that m always represents the slope, and the slope is 2. You can see here that we have y minus y1, right? This is y minus y1. So it's going to be the y coordinate of the point. So if I go y minus, well, the y coordinate is negative 3. And this one is going to be x minus the x coordinate, which is positive 1. And what you can do is simplify this, because in the first bit you have y minus negative 3. That's the same as y plus 3. Then we do that as 2, and then x minus positive 1 is just x minus 1. And you can see that's how we built that equation right there. And you can do this using any point. They just told us to choose A, but if we chose a different point and plugged those values in, it would still be the same graph, the same line. So let's do that again. The graph of y minus 1 is equal to negative 2 over 3x plus 4 is shown on the grid. Determine the slope of the graph. So they give us point B. It looks like we can use this point right here to find our slope. The slope is going to be negative 2 for our rise and positive 3 for our run. So our slope is negative 2 over 3. Surprise, surprise, because look at that. And then list the coordinates of point B. So it looks like point B is at negative 4, 1, negative 4, and 1. Compare your answers in D and E with the numbers in the equation. So you can see that the slope matches. We already talked about that. The x coordinate matches. It's 4 and 4. This one's negative, but that comes with the equation. And then 1 and 1 there. Consider the graph of the linear equation y minus y1 is equal to m multiplied by x minus x1. Based on your observations in C and F, state the slope of the line and write the coordinates of one point of the line. So we know what's happening in this y minus y1 is equal to m x minus x1 is that m is our slope and x1, y1 is one coordinate or 1 point on the line. So had I only known the slope and 1 point, you could still write the line, or the equation of the line. We know that the general form is y minus y1 is equal to m x minus x1. And so we know that y1 is our y value of that point, so it's 1. X is negative 2/3, and then our m is negative 2/3, our slope, and then we have x minus x1. So the slope, or the point there's negative 4, so we're subtracting negative 4. So you can rewrite that if you want to make it a little bit nicer, because right here, when we go x subtract negative 4, well, when you subtract a negative, it becomes a positive. You can see that is the same equation that we get right there. So that is basically that is point slope form of a line. We're going to skip the next page here to here, top of 409. Point slope equation of the line. So we just talked about that. Y minus y1 is equal to m multiplied by x minus x1, where m is the slope of the line and x1, y1 represents a point on the line. So if we knew several points on the line, we could have several different equations that describe or represent the same line. The point slope equation is used when we have the slope of a line and the coordinates of any point on that line. Any point. So it says here, state the equation in point slope form of the line through the given point and with the given slope. So that means this is our slope right here, and this is our point. So what we can do is, well, I'm going to just write the general form up here. Y minus y1 is equal to m x minus x1. So we can say, well, y minus 5, because that's our y coordinate, is equal to, our slope is 3, x minus, and our x coordinate is 6. And that's the equation. Things get weird with negatives, but that's okay. So again, this is our slope, negative 4, and then this is our x1, y1. So we can write that equation as y. Oh, what happened? There we go. We can write that as y minus negative 1 is equal to negative 4 x minus 1. And then we can clean up that little section right here, because when you subtract a negative, it becomes y plus 1 is equal to negative 4 x minus 1. And the last one, we can say y minus, so this is our y1, x1, and m. So y minus negative 8 is equal to 1/2, that's our m, our slope, and x minus negative 9. And then again, we just have to switch the signs. So y subtract negative 8 is the same as y plus 8 equals 1/2. X minus negative 9 is the same as x plus 9. And that's the proper equation. We don't want to leave it like the one on the top, because it's just not correct, right? It's mathematically correct, but it's not in the simplest terms. Okay, in each case, the slope of a line and the point on the line are given. Determine the equation of the line in slope-intercept form. Okay, so this is where things get a little bit trickier, but not too bad. So we are given a point and a slope. So we're given a point and a slope. So we are going to write our equation in point-slope form because those are the pieces of information we're given. So our equation is going to be y minus 2 is equal to 5x plus 5. So it'll be subtract a negative 5. And then that's the equation in point-slope form. And to switch it into y is equal to mx plus b, you notice here that y is all by itself. So we just want to get y completely by itself. So what you can do, the first thing I'm going to suggest is to factor this 5 in throughout the brackets. So we have y minus 2 is equal to 5x plus 25. And now what you want to do is add 2 to both sides to get y by itself. Add 2. And we are left with y is equal to 5x plus 27. And now we have that line in point-slope form here and slope-intercept form here. Let's do the next one. So we're given a point and a slope, so that is going to tell us that we need to write our equation in point-slope form, which is y minus y1 is equal to mx minus x1. So we're going to plug those numbers in now. Y minus 4 is equal to negative 7x minus negative 3. So if we're going to subtract a negative, it's going to become plus 3. First step we're going to do is factor that negative in, that negative 7. So we have y minus 4 is equal to negative 7x minus 21. And then we can add 4 to both sides to get rid of that. And we have y is equal to negative 7x minus 17. So not only do we write it in point-slope form, but we also wrote it in slope-intercept form. Awesome. One last example. The line on the grid, maybe we'll do the next one too. The line on the grid passes through at least 2 points with integer coordinates. Determine the equation of the line in slope y-intercept. So the trick here is, like, if we want to put this into slope y-intercept form, we need the slope and the y-intercept. But if you look, if we zoom in, maybe we're not going to zoom in. If you look at our y-intercept, we're not going through an exact integer point, right? You can see that y is negative 4 is right here, and I don't know why that's happening. And y negative 5 is down here. Why do they keep disappearing? Okay, anyways, you get the point. Our line isn't going through an exact value, so we can't confidently say that's negative 4.5 because we don't know that. But what we can do is write our line in a different, or write our equation in a different form, and then switch it to slope y-intercept form, or slope-intercept. So what I'm going to do is find the 2 coordinates that I'm going to use. So it looks like I've got one right here and one right here. So the first thing I want to do is find my slope. Well, it's going to go down negative 1, 2, 3 over my run is 1, 2, 3, 4. So negative 3 over 4. I have 2 points on the line here. that I can use, right? This one is negative 6, 0. And this one is negative 2, negative 3. If you use either of those, your answer is going to be correct. But it's actually easier to use this one because the y value is already 0, which makes things so much easier. So the point I'm going to use is negative 6, 0. So I can write the equation of the line in slope or point slope form, and I can say y minus 0 is going to equal negative 3 over 4 x minus, so it becomes x minus negative 6, which when we subtract a negative becomes positive. So that's awesome. We want this in terms of slope-intercept form. So, well, this negative minus 0 we can just get rid of because it doesn't really change anything. And I can also factor this negative 3/4 in. So if you just left it out, it wouldn't be correct. You have to factor it in because it's going to change the y-intercept. So we have negative 3/4 x, and then we have to multiply, I'll do it off to the side here, negative 3/4 multiplied by 6. So when you multiply fractions, you can just multiply the tops together. So negative 3 multiplied by 6 is negative 18, and 4 multiplied by 1 is 4. We can reduce this to be, divide both top and bottom by 2, and we get negative 9 over 2. So I can write that as minus 9 over 2. And that is my line in slope-intercept form. So this is point slope form, this is slope-intercept form. And the last thing we're going to do is just be able to grab the coordinates from the equation. So it says state the slope of the line and write the coordinates of the point. So slope in this case is 1 over 7, which is right here. And my point as an x1, y1 is going to be positive 4, negative 11. So we're doing opposite values. So if it's a negative 4 by the x, then the x coordinate is positive 4. And if it's positive 11, then the coordinate is negative 11. I'll do one more quick one here, or maybe that's it. We'll call it there. Oh, one more. Sorry. So again, this one, our slope is negative 5 over 3, and our points are going to be 7 and 9. Those negative signs are part of the equation, so we leave them. In this case, in C, we just have y, and then the rest of it looks correct. So that must mean that our y coordinate is 0, and our x coordinate is 6, and our slope is negative 3. And in the case of D, you can see that it's in slope-intercept form. So in this case, I think the easiest way to do it is to factor out negative 3. And what happens is I've got x plus 2. And now it's actually in point slope form. So I can say my slope is negative 3. And my point is going to be negative 2, 0. That's it. Hopefully that makes sense. Thanks for watching. Don't forget to like and subscribe.